Hello everyone, in this video I'm going to explain one of the most important concepts in computer architecture, the fetch execute cycle. So, what is the fetch execute cycle? The fetch execute cycle, also known as the instruction cycle, is the basic process that every CPU follows in order to run programs. This cycle involves three main steps: fetching an instruction from memory, decoding it to understand what needs to be done, and then executing the instruction to carry out the required operation. This could be anything from adding numbers to moving data or even displaying something on the screen. This process may sound simple, but it's happening millions or even billions of times per second inside the computer. Every single task, whether it's opening a web browser, playing music, or running a video game, is broken down into tiny instructions that are processed through this cycle. Now, why is the fetch execute cycle important? It's because the cycle is the foundation of everything a computer does. The speed and efficiency of this cycle directly affect how fast a computer performs. If the CPU can complete more cycles in less time, it can process more instructions and perform more tasks. To improve this cycle, modern CPU designs use several techniques such as pipelining, which allows multiple instructions to be processed at once in different stages. They also use caching, which stores frequently used data closer to the processor to reduce delay. In more advanced processors, like the Intel Pentium 4 that we studied, features like trace cache and hyperthreading are introduced to make this cycle even faster and more efficient. In short, the fetch execute cycle is like the heartbeat of the CPU. It keeps everything running. Understanding it helps us appreciate how powerful and efficient modern computers really are. Thank you for watching.
Hello and Assalamualaikum everyone. Today I'll be explaining the key organizational features in modern CPU architecture as highlighted in the image. These features focus on improving performance, efficiency and speed in processing. So what we have, first thing first, we have NetBurst microarchitecture. So what is the NetBurst microarchitecture? The NetBurst microarchitecture was designed with a strong focus on high clock speeds reaching up to 3.8 GHz. To support such high speeds, it uses very long pipelines, often 20 stages or more. This means more instructions can be in different stages of execution at once and allowing for faster overall performance. So the second one is we have hyper pipeline technology. So hyper pipeline technology builds on the idea of longer pipelines by allowing deeper levels of instructions processing. So this lets the CPU handle more instructions per cycle and increasing throughput. However, this also comes with a drawback. It can cause high latency when a branch misprediction occurs. And the third one, we have trace cache. Unlike traditional instruction caches that store raw instructions, the trace cache stores already decoded micro operations. This is important because it skips decoding step, which saves time and accelerates the instruction fetch stage. And next we have out of order execution. So in out of order execution, the CPU does not wait for previous instructions to finish if a later instruction is ready to go. As soon as data for an instruction is ready, it gets executed. This boosts CPU efficiency and throughput, especially in complex tasks where waiting would slow everything down. So the last one, we have branch prediction unit, and we call BPU. So the BPU is like the CPU's guesser. It tries to predict the next instruction to execute. By doing so, it reduces idle time and keeps the long pipelines full. This is especially crucial in avoiding performance drops due to branch stall. So in conclusion, all of these organizational features, NetBurst, hyper pipelining, trace cache, out of order execution and branch prediction, work together to optimize how modern CPUs and accelerate. They aim to make instruction processing faster, more efficient and smarter. So that's all from me. Thank you.
Welcome and hello everyone, my name is Muhammad Faizari and today I would like to explain about the fetch execute cycle in the Intel Pentium 4 processor. I will focus on the first 4 stage, which is fetch, discard and dispatch and issues, and then lastly execute. First, CPU begin with the fetch stage. In this stage, the instruction is taken from the instruction cache. Pentium 4 has a special cache called trace cache, which is store ready discard instructions, also known as micro operations or micro ops. The CPU also use a branch predictions unit to guess the next instruction, so the process does not slow down. Next is the decode stage. In this stage, the CPU changes complex x86 instructions into simpler micro-operations. It uses 3 parallel pipelines, so it can decode multiple instructions at the same time. This helps the CPU process instructions faster and more efficiently. Then we have dispatch and issue stage. The decode micro ops are sent to reservation stations, and from there a schedule decide when each micro ops is ready to be executed. After that, they are sent to the correct execution unit like ALU or memories unit. Lastly, we have the execute stage. This is where the real actions happen. The ALU handles logics and maths operations. The FPU works with floating points number, and the loads or store units deal with memory. Pentium 4 use out of order executions, which means the CPU can execute instructions as soon as they are ready, even if they are not in order. This makes the processor faster and more efficiently.
Assalamualaikum and good day everyone. Today I will explain 2 final and critical stages in the fetch execute cycle of the Intel Pentium 4, which are the write back stage and the retire stage, followed by a quick summary of the whole cycle. The write back stage is where the result of executed instructions are saved, either to the register file or memory. It marks the completion of the execution process, where the data becomes officially available for operations. What is interesting about the Intel Pentium 4? Intel Pentium 4 is that use out of order execution. This means instructions don't always finish in the other relay appear in the program. To prevent confusion or incorrect results, the CPU uses a special buffer called the reorder buffer or ROB. The ROB ensures that all results are written back in the correct program order, even if they were processed out of order. This helps maintain accuracy, prevent data conflicts, and ensures that the CPU's output behaves exactly as expected by the software. After the write back stage comes the final step, is the retire stage. In this stage, instructions that have been fully completed are officially removed from the pipeline. Think of it as checking off a task from a to-do list. It's done, confirmed and cleared. This stage is especially important in out-of-order CPUs because it makes sure that only correct and completed instructions are retired. The retirement process ensures that instructions were executed correctly, that no error were left behind, and that system resources are freed up for the next instructions. Without the retire stage, the CPU could lose track of what's been completed, which would be dangerous in mission-critical systems. To summarize the fetch execute cycles in Intel Pentium 4, Intel Pentium 4 use advanced techniques such as trace cache to store decoded instructions and speed up fetching. Out of order execution to boost performance by executing ready instruction immediately, and branch prediction to keep the pipeline full and avoid delays. Each instruction goes through several stages: fetch, decode, dispatch, execute, write back, and retire. The write back stage ensures results are stored properly, while the retire stage makes sure those instructions are officially complete and clear. All of this allow Pentium 4 to reach high clock speeds up to 3.8 GHz and run programs more efficiently than older CPUs. In conclusion, understanding the write back and retire stage help us to appreciate how modern CPUs maintain speed and correctness. Even when instructions are processed out of order, the entire fetch execute cycle is a teamwork of stages working together to ensure smooth and accurate computing. Thank you for your attention. Bye.